Okay, this is a continuation of our last video. So we're going to continue to talk about solving by factoring. Now, in our last video in the quadratics, our a was 1. That made it a little bit easier to factor them out. In this video, our a will actually be a number. So, let's have an example. 5x squared minus 17x plus 6. Okay, we can still use our trick for these. It's a little bit more complicated though. So let's try that. What are all the factors of 6? 1, 2, 3, and 6. But now, you know that we talked about that I have to put them over the factors of this number. So where are all the factors of 5? 1 and 5. So I have the same list with 1 over them, and I have the same list with, not over them, but under them, 5. So I have to make a fraction with all of these denominators equals the factors of that a. So I have twice as many possibilities now. 1, 2, 3, 6, or these fractions, 1/5, 2/5, 3/5, or 6/5. So let's go ahead and try this. Now, there's really no easy way to do this. I have to almost guess and check. So on these, instead of starting with the 6, I like to start with the first term. What are all the ways I can multiply together to get 5x? Well, thankfully 5 only has 2 factors, the 1 and the 5. So one has to be 1x and the other has to be 5x, because that's the only way to get 5x squared. Okay, now you'll notice that this number is my denominators here. So this number over here will have to be one of these numerators. So what's the way to get 6? I can have 1 and 6, or 2 and 3. Now here it's almost just a guessing game. Let me go ahead and figure out my signs first. So I have a negative and a positive. So we know that'll be negative and negative. Let's try the 1 and the 6. Okay, so I'm trying this vector and this one. If I FOIL this back, I will have 5x squared, that's good, minus 6x minus 5x. That would give me negative 11. So that's not right. Now, let's put in the 2 and the 3. So 2 and 3. Let's check it. So 5x squared again, minus 3x minus 10x plus 6. That'll be negative 13. So that's not right either. Okay, a lot of times now people would start giving up. So we don't want to do that. We know it has to be one of these combinations. So let's go ahead and change these numbers, or switch them around. Let me get a green. Let's switch around and make this number A3 and this number 82. Now it would look like we're doing the same thing again, but notice that we have to multiply by the 5. So that's technically going to give us a different answer. So x times 5x is 5x squared. X times negative 2 is negative 2x. Negative 3 times 5x is minus 15x. And then negative 3 times negative 2 is plus 6. So this does simplify back to here. And so these problems are a little longer. They're not anything you actually can't do. Even for me, it takes me quite a while to put them in and then guess and check. So just don't give up. Okay, if you would like a kind of a trick to do these with, you could graph them on your calculator. Okay, and the graph for this, where's the intercept for that? That'd be at positive 3, isn't it? Because x minus 3 equals 0, so x would be positive 3. If you looked at that, you could say, okay, and then the other intercept would be positive 2/5. So 2/5 would be somewhere right here. You could say, well, I don't know exactly what that point is, but I know this is a 3. And so if I flip the sign, I would get the x minus 3 here. And then I could figure out my other term. Okay, let me show you how that would work. I'm doing it on my calculator real fast. Okay, so they gave you this problem and they said to factor it out. And you're feeling a little bit lazy and you don't want to try this on your own. And in fact, let's not do this until you've done a few by yourself, because you really need to know how to do it by hand. But let's figure it out on our calculator here. And your calculator graphs something like this. Okay, let's figure out what the factors will be from that. So I'm going to count over here. 1, 2, 3, 4, 5, 6, 7. Negative 7. So I know x equals negative 7. Now, I want to put that into my x plus or minus something equals 0. So I'm going to add 7 to both sides to say x plus 7 equals 0. So that's one of my factors. Now, I'm going to come over here, and this is my 1 slash. So the other cross is in front of the 1. So I know it's some sort of fraction. So I can't read it off because it doesn't cross at exactly a good spot. But I can tell from this factor what my other ones should be. So I know I need to multiply two things together to get 3x squared. And I have a plain x here. So what does the other number need to be? 3x. That's the only way to get 3x squared. Okay, I have a plus here. And then my sign is a minus, so I know I need to have a negative here. And then, what's the only way to get 7? 7 and 1. Which gives us, if we said 3x minus 1 equals 0, and I added 1 to both sides, so 3x equals 1, and divide by 3, so x equals 1/3. That would be that fraction. So using your calculator is a nice shortcut to do them with. Just remember that you shouldn't depend on this, you should be able to do it by hand, because next year in college algebra, or if you actually wait until college to take college algebra, they will not give you a graphing calculator. You have to do these with just a regular scientific calculator, and so you'll need to know how to do them by hand. Okay, we can use our special patterns on this, so that if you see a quadratic that has no middle term, has a minus for the sign in the middle, and these two are perfect squares. That's the difference between two squares. So we need to take the square root of the first term, and the square root of the first term is 3x. We need to take a square root of the second term. Square root of 64 is 8. And when we put them inside our two parentheses, we'll have 3x plus 8, and the exact same thing, 3x, except with a minus sign. And that is our factor of two squares. Now, let's say they gave you this. You say, okay, it looks in the form of difference between two squares. But what's the problem? Problem is 5 and 45 are not perfect squares. But do you see that I could take a 5 out of both of them? So I need to factor out a monomial first. And that'll leave me with 9 here, which is the difference between two squares. So when I factor that out, I will have plus 3, x minus 3. Now, a common mistake here is that students will forget to go ahead and put the 5 here, and they'll just say it's x plus 3 times x minus 3. The 5 is actually part of the answer, so you need to have it there. Okay, let's have one more kind of odd example. Okay, notice that I can divide both of these by 4. If I pull a 4 out, I would have negative 4x squared plus 3x. I don't know why that's again. 3x. Well, that's still not the difference between two squares. In fact, there's no way that 3 can be a square. So, I can't really do anything there. But do you see how they both still have an x term? Let's go ahead and take that x term out. And factor it out. So I'll have negative 4x plus 3. And I could either leave it like that, or some people even factor out the negative sign to get me negative, or positive, x, 4x, minus 3. Okay, if they said from here were the solutions, don't let this odd example fool you. Either this term has to be 0 or that term has to be 0. So either negative 4x equals 0, so that means x itself is either 0, or 4x minus 3 equals 0. So I'm going to add 3 to both sides, divide by 4. So x equals 3/4. Okay, these are not hard, just like I said, a little strange.